Okay guys, we will continue about memory organization, error checking. Most memory available today is highly reliable. Most systems simply have the memory controller check for error detection. Memory chip with built-in error checking typically use a method known as parity to check for error. High-end servers often have form error checking known as error correction code (ECC). ROM differ from RAM with no write control. Parity checking. Parity chip have extra bit for every 8 bit of data. Parity can be divided into even parity and odd parity. Example for parity, if the total number of 1 is odd, the parity bit set is to 1. If the total is even, the parity bit is set to 0. When the data is read back, the total is add up again and compared to the parity bit. If the total is odd and the parity bit is 1, then the data is assumed to be valid and is sent to the CPU. But if the total is odd and the parity bit is 0, the chip knows that there is an error. Odd parity work the same way, but the parity bit is set to 1 when the total number of 1 in a byte are even. Parity error can be caused by RAM chip that are unable to hold data reliably. The problem with parity is that it discovers error but does nothing to correct them. Error correction code. Computer in critical position need higher level of fault tolerance. High-end server often have form error checking known as error correction code. Like parity, ECC use additional bit to monitor the data in each byte. The difference is that ECC use several bits for error checking. ECC memory use a special algorithm not only to detect single bit error but actually correct them as well. Cache memory. Cache memory is a critical component of the memory hierarchy. Compared to the size of memory, cache is relatively small, very expensive compared to memory. Cache sit between normal memory and CPU. Cache contains copies of session of main memory. Okay. When the processor attempts to read a word of memory, a check is made to determine if the word is in cache. This is a characteristic of memory hierarchy. We are increasing distance from processor in the access time, inclusive level 1, level 2 is a subset of what in main memory, the subset in secondary memory. Okay. Memory interface. Assume all access to memory cause block of keyword to be transferred. Once copy to cache individual word within a line can be accessed by CPU. If the two multiply word is memory, there will be two multiple n divided by k word in memory. Factor in cache design, size, mapping function, line replacement algorithm, write policy, block line size, number and type of cache. Multiple processor system. The computer industry has been driven by an endless quest for more and more computing power. Making computer this small may be possible, but then we hit another fundamental problem: heat dissipation. The faster the computer runs, the more heat it generates. The smaller the computer, the harder it is to get rid of this heat. Okay. And one approach to greater speed is through massive parallel computer. A system consists of 1,000 computers spread all over the world is no different than one consisting of 1,000 computers in single room, although the delay and other technical characteristics are different. Okay, see the example. Share memory. Okay. Shared memory multiplexer. B is message passing multi-computer. C, internet wide area distributed system. Multiprocessor. A computer system is which two or more CPU share full access to a common RAM. The CPU can write some value into the memory and then read the word back and get different value. Interconnect. A tightly coupled CPU that do not share memory, each one have its own memory. This system also known by a variety of other names, cluster computer or cluster of workstation. Multiple multi-computer hardware interconnection topology, single switches, ring topology, grid, double torus, cube, and 4D hypercube. Okay, thank you everyone.